I'm going to go ahead and do 6 and 7. Let's see if we got it right. This shouldn't take very long. I'm going to go pretty fast because you already have an answer. This is my b, -1. My slope is -2. So down 2 and right 1 because I put it over 1. Can't forget that. Fix your problems on the side if you got this wrong. Okay. All right. Go the opposite way. All right. Solid line because it has a line under it. So I'm going to use my trusty dusty straight edge because I left my ruler in the classroom. And I am in the lab recording videos right now. Okay, now we need to do y equals 3 would be there. Okay, and since it has no line under it, this line should be connected with a dash. 1, 2, 3 on the y, dash, 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 dash. Okay. Sorry. Now, if you did what I did, made this mistake of just graphing them both, excuse me, without shading, it's really not a mistake. You just got to know how to shade it with both of the graphs already there, or both of the lines already there. So greater than this line. So that's him. Greater than means up. So that's up. So you'd have to shade even on top of the other line. Now we need to go to our y is less than 3 line, just him, and below is where the way I need to shade. So make sure you go from the line, and that means you have to come over here and overlap. You want it to overlap correctly, and so you should see the double shaded area, which is here. Okay. Now I want to check to see if I have, I want to check to see if the solutions I pick, if they really are solutions. So let's pick this point here. And I see that that point is 1, 2 on the x, 0 for the y, so that is 2, 0. I want to know, is 2, 0 a solution, yes or no? Let's take the values and plug them in here. So, if y is greater than or equal to -2x minus 1, plug in 2, plug in 0. Let's figure this out. -2 times 2 is -4. Minus 1, bring everything else down. -4 minus 1 is -3. Now ask yourself, excuse me, is 0 greater than or equal to -3? So if I have $0, is that a better situation than an owing someone $3? Yes. This, therefore, is a solution for that part of the system. Now you must check the second one, because if the second one says no, then this would not be a solution for this system. It's just a solution for the top, the first equation. Let's try the next one. Y is less than 3. Well, the only letter I have to plug in is y. And so when I plug in 0, is 0 less than 3? Having $0 is not as good as having $3. Very true. 0 is less than 3. So it works for that. Therefore, this is a solution for this system. It works for any point. I want to try one more. I want to pick a point on the dotted line. 1, 2, 3. So that is 0 for the x, 3 for the y. So that's 0, 3. So let's check 0, 3. Y is greater than or equal to negative 2x minus 1. This is x, this is y. Plug in my x. Plug in my y. This times this is 0. Minus 1. 0 minus 1 is negative 1. Is 3 greater than or equal to negative 1? Yes, it is. So we have a check for one of the systems, one of the equations in the system. Let's try the next one. It has to work for both to be a solution. Don't forget that. Y is less than 3. I only need to plug in 3. 3 is greater than 3. Is that a true statement? No, 3 equals 3. It's not greater than 3. It's not true. So this is not a solution. And that is exactly what we have learned when it's on a dashed line. It's not a solution. And the point we chose was on that dashed line. Okay, let's go ahead and do number 7. Make sure you got it right. Well, let me do it because you already did it. 1 is b up 1 over 1. So you should have that. And I'm going to use my trusty dusty box here and use a dashed line. I'm pressing too hard. I'm off the dots. Try that again. Lining it up. Not too bad. Not too shabby. Okay, it says greater than, so I want to shade above. And that would be this way. And then I'm going to do the next one. Start at 5. 1, 2, 3, 4, 5. I'm going to go down 3. 1, 2, 3, and to the right 1. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. And there aren't enough boxes to go the other way. It is also going to be dashed. And it says to shade greater, so I have to shade even greater from up here. I don't just shade greater for that. I shade greater for all of this. Aha! I see the solution area. And let me label, because I didn't do that on the last one either. Solution area. Solution area. Yes, it is a solution. Yes, it is a solution. Yes, it is a solution. No, it is not a solution. Okay. So now we need to do number, and remember, if you did it wrong, correct it over here. If you remember the other examples I did, the solution area, I rewrote it over here, but I'm not doing that this time because I want you to correct it over here. And since we say that this point here is not a solution, let's prove it real quick. 1, 2, 3, 4, 5. So that's 0 for the x, but 5 for the y. So 0, 5. Y is greater than x plus 1. So 0 plus 1, that's my x, that's my y. 5 is greater than 1. Is that true? Yes. Y is greater than negative 3x plus 5. Plug it in. 0 here. Plug in the y is 5 here. That's 0, so I'm left with 0 plus 5, which is 5. Is 5 greater than 5? No, it is not. Therefore, this is not a solution to this system, only a solution for the first one, which is why it works on that part of the line. Awesome. Number 8. We can graph the top, so negative 2. We can go up 1 over 1. Do the opposite for the other way. If you need me to pause, just say pause. And I'm going to draw a solid line. I did that twice because the first one was off. It says to shade greater than above. Shade up. The next one, I'm going to move the 2x and solve it for y. And we just did this on graphing, so this should be very familiar. Now it gets interesting. If you drop off that negative, you will miss this problem. When you have inequalities and you are dividing by a negative number or multiplying, you won't see us multiply very much by a negative, but you will see a lot of dividing. First, remember that's a 1, invisible 1 there. Now let's divide off to get rid of that number because it's multiplied to that. When you divide, this inequality symbol will always change directions. So it is no longer going to be greater than, it becomes less than after you divide by the negative. So this cancels, that's y, and that becomes negative 2x, and that becomes minus 1. So that is what you graph. So negative 1, which is here. Going to go down 2 and right 1. Down 2 and right 1. And then go the other way to get the other points. Okay, so I draw a solid line. I missed it again. Guess I should have held it at the top. Aha! I got it that time. I need to shade below. Excuse me. Now I find the solution area, which is here. And no matter where I pick, I have solutions here, inside the double region, as well as on the other line, because both lines are solid. So the dots are my solutions, and we're done. Let's move on. Okay. The second one is already solved, but the top one is not. Okay? So I am going to stop this video, let you get started on number 9, see how far you get, and then we'll start back and see if you graphed this one correctly. So graph him, make some notes. I want you to graph this one and then solve this one for y and try to graph it. So let's see how you do.